today we are going to solve a previous year question of UPSC Maths. That the part of linear algebra means paper first. So this question has been asked in 2023 of 15 marks. 15 marks, and question is find the rank of the matrix. And find the rank of matrix is equal to question. And you know how to find the rank. Means first reduce the matrix in echelon form, and then number of non-zero rows in reduced echelon form matrix is called the rank. So first we will change the given matrix into the echelon form by using the elementary row operations. And what are the elementary row operations? We know that elementary row operations are means Ri, any row is replaced by Rj. Second is the we can replace any row with the you can multiply, that means you can change the any row Ri by the k times Ri, where k not equal to 0, and third one is the any row Ri can be replaced by Ri plus something k time Rj, where k not equal to 0 and I not equal to j. So using this elementary row operation, we can reduce the given matrix into the echelon form, and then in reduced echelon form, number of non-zero rows are called the rank of the matrix A. And by reducing the echelon form and finding the rank, we can solve the system of linear equation to find the number of linearly independent solution. Also check the solution exists or doesn't exist, whatever that means also call the consistent and inconsistent problems in system of linear equation. So now in this question we have to find only the rank. So question asked in 2023 of 15 marks to find the rank of the matrix, given matrix A equal to this. So we'll see how to find the rank. So we will use this operation, we know about it. So first we will reduce, so change the matrix that will be equivalent. So first that is the one, so make it the, we know that this is the, you can take it as the pivot element and make rest of the element below the one are 0 by using the row operation. So we can make it the 0 by using the R2. We can replace the R2 by R2 plus R1. So now first is the 1, 2, minus 1 and 0, and this will become the 0. So same operation here, the 5 and then minus 1, then minus 4, and also make it the 0. Then we can replace the R3 by R3 minus 2 times R1, minus 2 times R1, then this will become the 0. And now R3 minus 2 times R1, that means 4. So we get the minus 3. Again R3 replaced by 2, R1 means 3 and multiply by 2 and we'll get the plus, so 5. And next minus 2 and 0, so minus 2. And we can also make the R4 replaced by R4 minus R1. So we can get here 0, 0, minus 1 and then plus 2 and then minus 1. So now we will, this is the now pivot element. So now next we have to consider this part only. So we will make it either 1, or also you can make it the, you can replace, we can exchange the R4 with the R3, so we can get the here minus 1. That will be more easy to make the rest will 0. So one more time we take the operation, so we get the what now next. So 1, 2, 3, 1, 2, minus 1, 0. Now we can take the here exchange, so we will get the 0 minus 1, 0 minus 1, 2 and minus 1. Now here 0 minus 3, 0 minus 3, 5 and minus 2, and second row will come at the place of R4. So 0, 5 minus 1, 0, 5 minus 1 and minus 4, means replaced by R2 replaced by R4. So now next Next we will make it the, this will be the pivot element. Now make it the 0, minus 3 and 5 0. So use the operation, row operation. We can get now here 1 2 3, that will be same 1 0. So now that is the 0, minus 1, 2 and minus 1. We have to make minus 3 as 0 to multiply by 3 and subtract, that means R3 replaced by R3 minus 3 times R2. So we will get the what here, the 0, and now multiply by 3. So minus 3 minus 3 0, and multiply by 3 6, 5 minus 6, that means minus 1, and then minus 2 and multiply by 3, so minus 3 and plus 3 means becomes the 1, and now here multiply by 5 and add. So this will 5 will become the 0, multiply by 5 and add, that means R4 replaced by R4 plus 5 times R1, 5 times R1. So now 0, now multiply by 5 add, then get the 0, multiply by 5 10 and minus 1, 10 and minus 1, that means 9. Now next multiply by 5, so minus 9. So next we have to make it now this one 0. So we can simply multiply by the minus, multiply by the 9 and add. So this will also become the 0. So next 1 2 minus 1 0, 0 minus 1, 2 minus 1, 0 0 minus 1 and 1. Multiply by the R1, that means R3, R4 replaced by R4 plus 9 times R3. So we will get the here, multiply by 9 and add, we will get the 0 0 0 0. Okay, so now we cannot reduce more. So now this is the reduced form, and that is the reduced echelon form, and these are the pivot element leading numbers of non-zero rows. So now this is the reduced form of the echelon form. So now what will be the rank? So rank will be the number of non-zero in, so just make it the equivalent. So therefore the number of non-zero rows in reduced echelon form equal to 4. Hence rank of A equal to 3, that is equal to the 3, and hence rank of the matrix A equal to 3. So it's a very easy problem, and also of the 15 marks we can solve in examination within the 6 to 7 minutes. We can find the rank within the 6 and 7 minutes is optimal. You can even solve this type of question within the 6 minutes. So that's a much better problem to find the rank. So I will discuss about the like the some another examples of the echelon form. Like the suppose this matrix is given 0 0 1 2 minus 1 0 0 0 0 0. Suppose you are given the 5 and 0 0 0 0 0. So this matrix is also in echelon form, as the number of zeros must be below the, that means 0 rows must be below the non-zero rows, and whenever the non-zero rows the leading coefficient. So if the first row has the non-zero number here, then second non-zero rows non-zero number must be, and that means right side of the previous one, that means at least right side, that either you can put here or you can put here. So this form is also the form of echelon form of matrix. So we can also take another example. Suppose we want to change the matrix into the echelon form. Suppose you are given the 0 1 2 3 minus 1 0 5 1 and 3 minus 1 2 1. We can change. So obviously first take the year 0, and now here -1 1 3. So first change the rows in such a way that here if any non-zero, that means in this column any non-zero number, then we have to be take the non-zero in the first row. So for example, you can take anyone either -1 or 3. So simply replace this row. So we will get the -1, 0, 5 and 1. So next will be the here 0, 1, 2, 3 and the 3, -1, 2 and 1. That means simply we have changed the R1 replaced by R2. Next, now make the rest are 0. So here already 0. So now we have to make this one 0. So we can make it by using the transformation, elementary row transformation, 0, 5, 1. Just multiply by 3 and add, so we'll get the 0. Second is the 0, 1, 2, 3. Make it the 0, multiply by 3 and add, we'll get the 0. So -1, multiply by 3, 15 plus 2, 17. And 3 multiply 1, that means the 4. So now all the elements below the 1 are 0, -1 are 0. So now next we have to make it that this is the pivot element, so we have to make it this 0. Below the this non-zero number 0, so we have to make it 0. So we can, what operation we have used, just write here, and so we have replaced 3 times adding, that means R3, replace the R3 plus 3 times R1. Next we have to reduce this one, that means we have to make -1 as 0. So next we can make it the -1, 0, 5, 1. So 0, 1, 0, 1, 2, 3. So now make it the 0. So we can add simply the R2 and the R4. So we can replace the here R2, that means R4 replaced by R4, not R4, R3. Only 3 rows here. R3 replaced by R3 plus R2. Then we'll get the what? 0, 0, 19 and 7. Now we cannot reduce further. So this is the reduced echelon form, and these are called the pivot element. So now number of non-zero rows in the given matrix is 3, and therefore rank of this matrix is also 3. So that is the rank of this matrix is also 3. Rank of A equal to 3. So we can reduce the given matrix in the echelon form by using the elementary row operation. And you know the application of to change the echelon form of the matrix by using the elementary row operations. We use echelon form of matrices, and you can also say that the elementary row operations to find the solution of system of linear equation. There are two types of system of linear equation. One is the homogeneous and second is the non-homogeneous equation, and we can solve the system of linear equation by using the elementary row operations and using the echelon form of the matrices. So we will discuss about the how to solve the system of linear equation both in case of homogeneous and non-homogeneous. We'll discuss about it in the upcoming videos. So thank you.